A cipher is a secret or disguised way of writing a code. In the digital world of computers, cryptographic algorithms are used as ciphers, along with digital keys, to convert plain text to ciphertext, and back again. This process is known as encryption and decryption. Algorithms are usually public information, and keys are usually secrets. But not always. Secrets must be safeguarded. Click on the underlined word for more information. Ciphers have been used since before the computer age. The simplest type of cipher is the substitution cipher. Julius Caesar used this method when encrypting messages. During the encryption process, the letters of a plain text message are replaced by other letters. Think of the Western 26-letter alphabet. If you shifted the letters by 3, the message Hail Caesar would become KDLOFDHVDU, which is the ciphertext. In order for the recipient of the message to decrypt the ciphertext, they would need to know the number of letter shifts and shift in the opposite direction. Thus, when shifting 3 letters to the left, K becomes an H, a D becomes an A, and so on. The number of letter shifts is the shared secret or key, and the method is the cipher algorithm. The transposition cipher is about rearranging letters and is more complicated than the substitution cipher. An example of a transposition cipher is the rail fence, so named because its schema resembles a fence. There can be any number of rows, but in this example there are 3. The plain text message is written in a zigzag form, resembling a rail fence. When enciphering the plain text, the letters are taken row by row. The message, "He had a bad day. What a day Dad had," would be enciphered to what you see on the screen. The receiver of the ciphertext would have to know the number of rows. This information is the shared secret or key. Click the button to see an example with 4 rows. The next cipher type, named the one-time pad, introduces randomness to the substitution method. Whereas the substitution cipher uses one shift letter value for the entire message, the keypad cipher uses a different value for each letter in the message. Imagine the sender has a 26-sided die, and they roll this die for each letter of the message. If the message began as "Hi Bob," and the first 5 rolls were 10, 4, 3, 11, and 18, then the message would be converted to RMEZT. This cipher type has a powerful feature. The randomness of the die ensures that there are no repetitive patterns, and that there is an equal chance of converting a plain text letter into any one of the 26 letters of the alphabet. The Caesar shift letter cipher has 26 possible combinations, which would not take too much effort to break using a brute force attack. However, if each letter had 26 possibilities, then a 5-letter message would be 26 multiplied by itself 5 times. This amounts to almost 12 million possible combinations. Without the help of a computer, this ciphertext is virtually impossible to break. Click on the underlined words for more information. Apply your knowledge and solve a one-time pad cipher. Use a pad of paper or the alphabet on the screen to help you solve this cipher. The ciphertext is GDCHV. The key is 5, 21, 15, 1, 7. Think of the alphabet as a continuous circle. and not linear with two terminal ends. Remember to encrypt the message. You would have to move right or clockwise. Therefore, you will have to move left or counterclockwise to decrypt the message. As an example, if your ciphertext was C and your key was 7, then you would have to move 7 letters counterclockwise. You would stop at A, but continue moving until you had counted 7. So the plain text would be V. Once you've completed the exercise, click Submit to verify that you have solved the problem correctly. The power of computers allows for more sophisticated encipherment, but the concepts remain the same. Two cipher types that are commonly employed are stream and block ciphers. Stream ciphers encrypt a stream of plain text data, 1 bit or byte at a time. Examples of stream ciphers are FISH and RC4. Stream ciphers are faster than block ciphers. Block ciphers break the plain text into blocks for encryption. The size of the block is determined by the size of the key. If the key is 256 bits, then the blocks to be encrypted will also be 256 bits. If the size of the message is 1 megabyte, then the message would be divided into multiple blocks, each one 256 bits in size. Common block ciphers that exist today are Data Encryption Standard, DES, Triple DES, Advanced Encryption Standard, AES, and Blowfish. You've completed the lesson. You can now achieve these objectives. Define what a cipher is. Describe the different types of ciphers. Describe how ciphers work at a high level.